Welcome to TileMapLayers in Godot. Oftentimes a dev will decide to do 2D tile maps because they think it's a solved solution so they can get it done real fast. And that's true to some extent. We've been doing them for a long time now, but there is a little bit of work to do, especially in Godot where the tutorials are a little bit outdated. Godot used to do it another way, and now they do it a new way, and all the tutorials are for the old version. It's really hard to look this up, so I decided I would make a little video tutorial walking you through the basics of how to do tile map layers in Godot. Now, the first thing I'm going to recommend is that you actually create a user interface scene rather than a 2D scene. Tile map layers are a 2D node, but in order to do eventing correctly, we want to make sure to create a user interface as our base node, and we'll talk about that as we get to it. Once we have this, we can create a tile map layer. There we go. Don't use this one. It's depreciated. No tile map layer. There we go. Now the tile map layer is basically just a grid of integers, and all it really does is display a tile set on screen. So we don't have a tile set. Okay, let's create one. Boom, there we are. We now have a tile set. There are currently 3 new windows that you have to be aware of here, and this is where things can get a little bit confusing. So, the tile set allows us to edit the overall set of tiles we're using. The tile map allows us to paint tiles. Obviously, we don't have any yet. And over here, we have the inspector. These are all really important. So, let's get started. Over here in the tile set, we're going to want to drop in any sprite sheet we want. Here's a tile map from Kenny. There we go. It automatically created it. And now we can go over into the tile map tab and we can just paint it. Oh, I was select. This is paint. So if we were to do that, we can go, select is great because it lets you select an arbitrarily large piece. You can see we can paint groups. If we set it to random, we can go ahead and select these and it will paint one selected at random from the things we've highlighted. The problem is that trying to actually make this into paths and stuff is really painful because you've got to manually select like, pain in the butt, right? This is where things like terrains come into play. So terrains are, there's no terrains. Well, how about in the tile set? Nothing jumps out at me saying terrain. Paint, maybe? Oh, look, terrains. There it is, terrains. Awesome, terrains. Do. Just need one terrain. Call this dirt. Call this grass and make it purple. Now you might be wondering, why is this over here? Why isn't it here? And the answer is, welcome to game dev. So in order to create these terrains, we do what's called a terrain peak pixel. So we're going to highlight which of these are involved, which makes them glow, makes them bright. And this hasn't actually defined anything yet. We've just told it which tiles are actually involved. What we do is we paint these third of a tile here. See this? It's like a third of a tile. These are called peak pixels, and they are going to tell the system which of the pixels are dirt versus which of the pixels are not. And this will allow it to create paths and stuff using this setup because it just looks at the tile next to you and says, this one's dirt, that one's grass. Which of the tiles do I have which have, that one has dirt and this side is grass? And so that's what we do. How exciting. All right, that's it. Go back over into the tile map and we can now paint dirt or grass. So we'll just go ahead and use this to block in a bunch of grass because we made a mess. And then we'll come over here to dirt and we will go ahead and create more dirt. And you can see that it immediately decides it's, trying very hard to create the right kind of dirt. However, Because of the limitations of the tile set we're using, we don't have all of the tiles necessary to always create all of the dirt. We don't have any dirt paths. So you can see that even though this is supposed to be a dirt path, it's going over and being too wide because we don't have any dirt paths. There's just not a tile for it in here. We could make one. There's no reason we can't have one. We just don't have it right now. That's game dev for you. We can also do things like, you notice how we get a lot of flowers here? We can always come back over here into the tile set, and when we paint, we can switch it over to probability, and we can make this have the probability of like 3. And we can make this have the probability of like 0.5. And then we come over here into tile map, and we decide we're going to paint dirt, or grass rather. When we do that, it will be mostly empty grass. So, with that in mind, this is called a tile map layer for a reason. If you would notice, if we try to paint something like this fence, it's going to end up kind of replacing the setup here. You can see how it's just cut the grass away. We have nothing. That's because it's supposed to go on its own layer. So if we were going to go back into this, we'll just paint that grass here. If we were to duplicate this and put it inside, we want to erase it because currently it's full of grass. So we'll just go into here, tiles, eraser, and erase. And you can see this is dark. That's because any tile map layer you're not currently painting is darkened, so you don't get confused. Now we can, of course, paint whatever sort of stuff we want. Here is a fence. Doop. Here is a house. Doop. Here is a tree. A bunch of pretty little trees. Doop. Doop. Whatever, right? So this is an easy way to do things, and you are going to end up with a lot of tile map layers. There's no way around it. You have tile map layers for virtually everything. For example, the player selects his unit in a tactical game, and the unit can move 10 spaces. How do you show that? Do you come up with some kind of complicated way to render that? No, you just create a new tile map layer, and you set the tiles they can move to be a specific color, and the rest is just not that color, and now you have a render. And how about when you move the mouse to where you want to move, you should draw an arrow from the unit to the mouse cursor. Well, you can just do that using a terrain, because you can set the pixels, those tiles as terrain tiles and use a terrain path follow, and it'll just be an arrow, as long as you have the tiles required to make an arrow. So tile map layers are extremely useful, extremely powerful, and I really recommend you get used to thinking in terms of having lots of layers. But that does not mean that everything should be a tile map layer. For example, what about an enemy? Should that be a tile map layer? Well, probably not, because enemies don't tend to move in tile units. Like if an enemy moves from 0.5 to 0.4, you don't want it to just go pop. You want them to smoothly move. And so in those cases, you simply add in a new, oh, no, that's not what I wanted. You add in a new sprite. And a sprite can be inside of a tile map. It can be on top of a tile map. There's no reason not to. And we can move this sprite around on the tile map. And when we decide we want to move this sprite from 0.5 to 0.4, we can do it using a pretty typical tween lerp, which I'll show you later in passing, but it's pretty straightforward. Now we can also do a lot of other stuff with this tile map. For example, right now it's quite small. If you see, this is the size of the screen here. So it's like the tiniest little corner of the screen. That's definitely not going to work. Well, we could try some kind of cute trick to make it as big as we want, or we could just say, make it bigger. Make it really big. Why not? We can also do things like rotation and skew. It's up to you to decide how you want your things to look. Now, if you want something complicated, like for example, if you want like a Mode 7 style pseudo 3D, you might have to render this onto a 3D object. Or for example, if this is supposed to be on an LCD screen in a house that you explore in a 3D game, obviously you're going to have to render it to a 3D object. But we're not going to discuss that here. I'm just letting you know that it is something you can do. The other thing you can do, or at least you need to be able to do, you need to be able to click on this. Everybody needs to be able to click on the game. I mean, I guess there are a few game types that don't need clicks, like if you're just using a controller or something, but I like to be able to click on this stuff, and unfortunately, there's no mouse-related stuff going on here. There's no events or signals related to it. There's no function for a mouse was clicked. Most people will tell you to use the onUnhandled input function. I don't recommend that, because if you use that more than once, which one gets it? Do they both get it? What order does it happen in? No. Try not to use unhandled inputs. Instead, try to capture the input, which is what we did. Here it is. Look, mouse-related stuff. Great. Let's go ahead and create a new built-in script. And then we can do this GUI input, and kaboom, there we are. We now have this input function, right? This will always obey the laws of bubbling. That is to say, if you put a menu on top of this, the menu will catch it rather than the control. This allows you to have things like you can click on a HUD element and stuff like that. You can use mouse fall-through rules. You do not have to worry about whether or not you're going to end up with the map trying to take control of the mouse, even if you've got something else that's supposed to be in control of the mouse, because it's a standard UI element. So let's do a little bit of fun with this. Let's go ahead and see whether or not this is a mouse move event. If event is input event mouse motion, there it is, why don't we go ahead and name this tile map layer to map, %map, which means that we can access it in here. Map.position plus equals event.relative. Oh, subcurrent. Okay, well, let's limit it to when we are holding down the right mouse button. And event.buttonMask. Oh, you see how it doesn't autofill? That's because it doesn't actually understand that this is an input event mouse motion. It hasn't really figured that out yet. So what we're actually going to do here is we're going to pass this off to a function. And what's this on mouse move? Oh, there it is. Now you might be wondering why we did that, and one of the reasons we did that is for autocomplete. So we can say button mask, there it is. If event button mask equals 2, now we can do it. So this is it. This says, are we holding the right mouse button and only the right mouse button? So now when we go ahead and run this, it only does this when we are holding the right mouse button, which obviously means that it's an easy implementation of a simple mouse pan. Works great, right? This is a little bit strange if you're not used to this, the idea of breaking this out for each individual thing. You can do it other ways, but I like to do it this way for one very important reason. Because it allows me to easily create signal handling. So we can here say, if event is input event mouse button, we can go ahead and do a function for that. Func on mouse button. Or even we can even do it here. Func on mouse event. And then func on mouse button. Event input event mouse button. So, why is it like this? Why is this better than putting them in here? Because what if we need another kind of map? What if we've got a town map and a battle map? What if we've got a world map where you walk really, really slowly to wherever you click, and then you've got a battle map where you have to select units and then have them move? You can simply descend from this, extend this, and override this function. Here's another thing you can do. And then here we can say if event dot button mask. Okay, so you might be wondering, what's the difference between button index and button mask? Well, button mask is a mask. So it goes 1, 2, 4, 8, 16, 32, 64. If you don't know why that is, look up flags, look up masks. You'll quickly understand what's going on there. It's counting in binary so that you can have multiple buttons held down. Button index is only available on input event mouse button because it is the mouse button that the input event is about. So even if you have all of the mouse buttons held, only the one that's triggering this event is in the button index. Now keep in mind that this is not necessarily a mouse down. It could also be a mouse up. But either way, we are now emitting it. And you might be wondering, well, why do we care about that? Well, for example, what if we give this map a script? Oh, starting to get complicated. We got 2 scripts now. Oh, look at that. So now this is able to take any mouse click we want. And we've connected it up to take a mouse click from this control, but we could make it however we would like. Now, you don't have to do it like this. I'm trying to show you some of the things you can do. Let's go ahead and make it so that when we click on this, it goes in and it just tells us where we've gone. There's a couple of ways to do that, but in the first case, we'll just go ahead and make it do it just with a print. So var tile vector 2I equals, what does it equal? If you look at that, we got 2 global and 2 local. This is not what we want. 2 global and 2 local are from the default control, the default 2D node. They're not from the tile map layer. What we want is map to local or local to map. Look at that. So we could just take the event.position, right? But the problem is event.position is not necessarily local to this map. It's local to the control, right? So what we actually want to do is take the global position, but we want to cast it to local. So just so you understand, what we've just done is we have this event that's giving us a global position. And because the map can be moved around, we need to cast that into a local position. And then we can cast that into the point on the tile that is being pressed. So if we were to do it like this and we were to hit F5, there we are. Down here is what we're looking for. This is 9.8. This is 7.3. This is 7.0. This is -3, -6. Yes, that's right. It is not limited to what is actually being shown, which means that we can have this other layer react to this stuff, and even if there is nothing on that layer, it will still trigger, and we'll be able to say drop down a building or whatever we want the player to be placing. So that's another thing we can do. What we can also do here is, just to show you, we'll go ahead and make this guy. We can send Guy over to that tile. So in order to do that, we're going to go ahead and say create tween property Guy position. Does Guy not have a position? Guy has a position. It's not it's a location, is it? I'm pretty sure it's position. Let's take a peek. Position. Yeah, it's not autofilling for some reason. Probably because I haven't saved. That's fine. We'll want to send him to the tile location, not to the integer value of the tile, because that's like pixels. We want to convert that into pixels. So we say map to local tile, and we'll take half a second to do that. Great, right? Now we do not have to turn this into a global. We could do 2 global, but because this guy is inside of the map, when the map moves, the guy moves. So he's always in local space. And he goes to the center of the clicked tile. See? From here, you can build it out any way you want. I wanted to make sure that you understood some of the most basic things about this. Just to show you one more little thing. If we were to create a new button, and we would put that button here. The button catches the input event. We do not have to worry about accidentally clicking on the map behind the button. Look at this. Isn't that beautiful? It's pretty smart. This is why I strongly recommend that you use a control as a backdrop and do not use unhandled input events. Just use actual input events. Hopefully this was useful. Let me know if you're still too confused about something. I didn't cover everything, obviously, but I covered the things that I had a hard time with. So hopefully you find it of some value.